Wow, we are here again. Welcome to Mathematics Meal, a lovely and beautiful program designed for all students, especially you that is watching the program now. Today on Mathematics Meal, we are going to continue with the concept of logarithm, and we'll be looking at the second part of logarithm. And in this second part, our business is to consider laws of what? Logarithm. Subscribe to our YouTube channel and make sure you follow us on Facebook at Mathematics and Science Meal. Our YouTube channel is Mathematics Meal 1. Just hit the subscribe button, like our videos, leave comments for us, and also share our videos. Make sure that you spread the good news of Mathematics Meal to all your friends and everyone around you. Thank you. So without taking much time, let's begin the journey today. All right. In our last video, we said that for us to solve problems in logarithm, we need the what? The laws of what? Of logarithm. That's what we need. The laws of logarithm. So what are these laws of logarithm? They are the basic rules that we need in order to solve problems in what? In logarithm. So laws of logarithm are the necessary rules. So laws of logarithm. Laws of logarithm are the necessary rules that we use in solving problems in logarithm. They are very necessary. So the laws of logarithm are the necessary rules that we use in solving what? Problems in what? In logarithm. So we use them in solving problems in what? Logarithm. The necessary rules, the basic rules that are required in solving problems in logarithm. What this means is that it is difficult for anyone to solve problems in logarithm if the person is not aware of what? The laws of logarithm. So without the laws of logarithm, you cannot do anything in what? In logarithm. Yes. There's no way you can solve problems in logarithm without knowing the laws of logarithm. And that's why it's very, very important that you pay attention to understand these laws of logarithm. So let's flow together as we look at these laws of logarithm. So we'll begin with the first law. We're going to list them, and afterwards we now begin to explain each of them. So we have the first law. The first law. The first law is given as follows: log m in base b plus log n in base b, same thing as logarithm of m times n in base b. Then the second law is given as log m in base b minus log n in base b is equal to log m divided by n in base b. Then the third law, we have that log m raised to power p in base b, same thing as p log m in base b. Then the fourth law, we have that log b in base b is equal to 1. Then the fifth law, we have that log 1 in base b is equal to 0. Then we have the sixth law, we have that log m in base b raised to power n is same thing as 1 over n, something as 1 over n log m in base b. And then the seventh law has two ways of writing it. I'm going to write just one of the ways. So we have log a in base b is the same thing as 1 over log b in base a. Okay, these are the 7 basic rules or 7 basic laws of what? Of logarithm. So when you want to solve problem in logarithm, you'll be looking at this. You can use any of these laws or combination of these laws to solve problems in logarithm. That means there are problems you want to solve in logarithm a single law will not be enough. So you may use 2 or more laws to solve such problem. And that's why you need to understand what each of the law stands for. So let's begin the explanation. So let's look at the first law. The first law is log m base b plus log n base b. We say it's something as log m times n base b. There are 2 things that are necessary here before you can apply this law. Number 1, you are adding 2 logarithms. That's point number 1. So when you are adding logarithms, the second point is that the base here and the base here are the same. The 2 bases are the same. So the base here, they are all what? They are all the same. So addition of 2 logarithms of the same base, or even 2 or more logarithms of the same base, all we need to do is to write the common log, because this log in base b, log in base b, so it's common to 2 of them. So then multiply the numbers. So when we are adding logarithms of the same base, we multiply the numbers in that logarithm under the common word base. So if I have log 3 in base 10 plus log 2 in base 10, I can simplify it. I can put it in simpler form by saying log in base 10 3 times 2, which will give me log 6 in base 10. So you see that. Why did I do this? Because the bases are the same, and what the operation we have here is what? Addition operation. So addition of 2 logarithms of the same base means to multiply the numbers in the logarithm under the common word base. Very clear. So if I have log 3 in base 10 plus log 2 in base 10, then I have to multiply the numbers under the common base. Now, something is going on in your mind as you're watching this, because someone is now saying, okay, what if they are not of the same base? Just cool down. We'll come to that. Just cool down. We'll come to that. We are still explaining the laws, so just relax, take your time and relax. We'll come to that. When the bases are not the same and you are adding, what are we going to do? Relax. We'll come to that. So that's the first law. The second law. In the second law, we have subtraction. You look at the second law, it looks like the first law. The only difference is the sign between the 2 logarithms. This addition, this one, subtraction. So when I have log m in base b minus log n in base b, when we had addition, we multiply. Now when we have subtraction, what are we going to do now? In the case of subtraction, what are we going to do? We use the second number to divide the first number. So this becomes m divided by what? N. So provided the bases are the same. The base here and the base here, they are the same. The base here and the base here are the same. Addition, the same base. Multiply the numbers under the base. Subtraction, the same base. Divide. Use the second number to divide the first number. That's what the second law is saying. That's what we mean by this law. So that when we begin to simplify, because in the next video, our interest will be to simplify logarithm. Yes, that will be our next video, to simplify expressions and terms that contain logarithm. Okay, so that's the second law. The second law. Let's look at the third law. Let's look at the third law. Remember, our business is to describe these laws. So the third law, we have log m in base to power of p in base b is something as p log m in base b. So the power of a number in a logarithm is the same thing as the coefficient of that log. So we can take this here. So if I have log 5 raised to power 2 in base 10, it's the same thing as saying 2 log 5 in base 10. This 2 is the power of this number. So if we have a logarithm in this form, I can write it in this form. If a logarithm is in this form, I can also write it in this form, depending on what I want to achieve. If writing it in this form will help me to solve my problem, to simplify the problem, good, I'm fine. I will put it in this form. But if I leave it in this form, I will not be able to get what I'm looking for. That means I need to transform it from this to this. So the power of a log, of a number in the log, is the same thing as the number multiplying the log. So this power of this number in the log is the same thing as this power multiplying the log. So log 5 raised to power 2 in base 10 is the same thing as 2 log 5 in base what? In base 10. Okay? So that's the third law. Now the fourth law is quite simple. Logarithm of any number to its own base is 1. So log b in base b is 1. So when the number and the base are the same, the logarithm will reduce to what? Will reduce to 1. Yes. When the number and the base are the same, the logarithm will reduce to 1. So what it means is that log 2 in base 2 is 1. Log 10 to base 10 is 1. So log x to base x is what? 1. Log mathematics, log mass in base mass will also give us what? 1. So when the base and the number are the same, the logarithm will reduce to 1. This particular law plays important role in various expressions in logarithm. So we must understand it. But that's the fourth law. Then the fifth law. We are all trying to explain the law. That's what we are trying to do. Now, when we now begin to solve problems in logarithm, we'll now have a better understanding of all these laws, because we're going to employ them in solving problems in logarithm. So we'll use real numbers now and see how these laws work with real numbers. So the fifth law, logarithm of 1 to any base is 0. So log 1 is 0. Log 1 is 0. If you have a calculator with you, you can press log 1 in your calculator. Log 1 in base a is 0. Log 1 in base 10 is 0. Log 1 in base 2 is 0. Yes, it proves the law of logarithm. It also proves the meaning of logarithm, because if 0 becomes the power of 2, 2 raised to power 0 will give us 1. You remember that in your indices, that when you raise a number to power of 0, you are going to have 1. So 10 raised to power 0 is also what? 1. So logarithm of 1 is what? 0, irrespective of the what? Of the base. Log 1 to any base is what? Is 0. Wow. So the sixth law, we have really progressed in this law. The sixth law, let's look at the sixth law together. The sixth law. What is the sixth law talking about? The sixth law. The sixth law deals with when the power is on the base. If you look at the third law, the power is on the number. So the sixth law is when the power is on the base. When the power is on the base, it's something as the reciprocal of the coefficient of the what? Of the log. So this is 1 over n log what? M to base b. So if I have log m or log, let's say I have log 10 and 5 raised to power 2. An alternative way of writing this, just following this law. This is a law, it's a rule. So you don't argue about laws. You don't argue about rules in mathematics. This is this. So if I have this, I look at it, this corresponds with this law. So I have to write this as 1 over 2 log what? M in base what? 5. Just following the law. So when the power is on the base, when it moves to multiply the log, it will be the reciprocal, 1 over the power. Unlike here, you see, we did not turn it upside down in the third law, because the power is on the what? On the number. The power is on the number, so it will just multiply the logarithm. Wow. So finally, the seventh law. The seventh law. In the seventh law, we have that log a in base b. If I change this base, if I reverse the base, so that a becomes the base and b becomes the number, we are going to have 1 over log b in base what? A. So when I change the base to the number and the number to the base, what will happen? The logarithm will turn upside down, will invert the logarithm. Look at this. This log a in base b is equal to what? 1 over log b in base what? in base A. Why did this happen? We just exchanged base to number, number to what? To base. All right, these are the 7 basic laws in what? In logarithm. And there is need for you to know these laws. Yeah, I'm telling you, you cannot possibly do anything in logarithm without what? The laws of logarithm. I'm the one telling you that, yes. And I mean every bit of it. So that's why you must take time to do what? Understand the concept of the laws of logarithm. But I know they will become clearer by the time we now begin to use them on real numbers. Yes, we are still using letters here, so it may still sound somehow. So when we start using them on real numbers, they will become clearer. Join me in the next class, because in the next class we are going to look at how we can simplify logarithms, yes, especially terms that have only one log operator, yes, terms containing one logarithm. That's where we are going to start, and we are going to apply the laws of logarithm in that simplification. I still remain your lovely tutor, your teacher, your brother, and also your friend. Engineer Ike Okechukwu is my name. See you in our next class. I love you.